Okay. Yes. So is my screen visible? Okay. So we'll start with the first topic, that is continuous versus discrete signals. Okay, now. So already learned, you have seen in your syllabus. Okay, signals and systems already you have learned. So now we will try the same concepts inside the MATLAB software. Okay, now. So after like every time when you open the MATLAB software, you should include the folders. Okay, desktop folder. So which you have created on the desktop. Okay, MATLAB programs. Go to the desktop. You will find the MATLAB programs. Select the folder. Click on the select folder. Okay. So these are the old programs which I have executed in the last class. Okay, now done. Okay, so now take down the definition. Open your notebooks. Take down the definition of continuous signals. Okay, so the first concept is continuous signals. Okay, so what it tells means when it consists in a EV, okay, electric vehicles. Let us take this topic inside the electric vehicles. So write on the definition. So it tells real world EV signals, measured continuously. Okay, continuously. For example, so here okay. Okay, now. So continuously, nothing but like values like motor, current, okay, battery, voltage, okay, or speed. Okay, these are known as continuous signals inside the electric vehicles. Okay, then we have discrete. Okay, discrete is nothing but a digitized signals used by the microcontrollers. Okay, those are called as discrete signals. Okay, first we need to comment this one. So first one, there is a continuous signal. Second one, that is a discrete signals. Okay, so we'll try examples on both the topics. Okay, so write in the definition of discrete signals, which is digitalized signals used by the microcontrollers. Okay, so this is a definition of continuous signals and the discrete signals. Okay, so now let us try the first program. Okay, so I will show how to how to execute these programs. First we will try the examples related to the continuous signals. Okay, so first we will take the variables t is equal to 0 is to 0 0.001 is to 1. Okay, so this is a simple array. Okay, so which is saved in a variable t. Okay, let us run this one. Before this you need to save the file, so I will save it as signals 1. Okay, signals 1. So when you run okay, so when you run it, it will show the values inside the command window. Okay, so here like you can see there are multiple values. Okay, so we have created the arrays using the t. Okay, this is a continuous signals. When you plot this signal means it will show the continuous signals. Okay, so let us try next example. Okay, t, now we have taken the t. Okay, so next we will take x. X is equal to let us do some calculations. Okay, let us consider it as a motor current. Okay, So we will plot a motor current, okay, smooth graphs of a motor current. So for that you need to write the formula, like x is equal to 10 into sine 2 into, okay, 2 into pi into 50 into t, okay, then close the bracket, semicolon. Okay, so this is the same. We are calculating both x and t. Okay, so here we have used a t value. Okay, so after this directly you can plot the graph of this calculation. Okay, so just you can write plot t comma x. Okay, let us see how it will show. Okay, now click on the run option. So wait for some time, it will generate the graph. Yes, so here we got the continuous signals. Okay, so how to set up this one means just click here. Okay, just zoom the area. Okay, sorry. Okay, now. Okay, so now you can clearly see the waveform. So it is in continuous waveform. Okay, now. So it is showing 0 to 1. So it is continuous, there is no discrete signal, it is a continuous signal. Okay, so you can see by zooming it. Okay, now like this. Okay, so this is a continuous signal which you have generated from the formula. Okay, now so just click on the plus icon and select this area and leave the mouse section. Okay, you will find the continuous signal. Okay, now like this you can zoom the graph. Okay, now so this is called as continuous signals. Done. Okay, so you can try multiple examples related to this. Okay, now so here we will just comment it down, or else you can try in another script. Okay, or else you can just type here only. Okay, so after this we will use another one program. So for that we need to change the formula. Okay, so if we will use x is equal to 48 plus 2 into sine bracket open, okay, 2 into pi into 100 into t, okay, close the bracket, semicolon. Okay, now so let us plot this one. Okay, so here we need to write this one here. Okay, okay, we got the graph here. Okay, now okay, so now we got the continuous signal. Okay, so there are multiple examples related to the continuous signal. You can calculate the some formula and you can obtain the plots. Okay, So these so this formula, first formula is to calculate the, so I will just comment it down. Okay, so this formula is to calculate the motor current. Okay, motor current in the electric vehicle. Okay, next this formula is to calculate the battery voltage ripple. Okay, battery voltage ripple. Okay, so then we will plot this graph and all. So there is another one formula for the acceleration profile. Okay, so then we have another formula for the regenerative braking current. Okay, so you can do it for multiple values. Okay, multiple formulas, using the multiple formulas and all. Okay, just you need to use this plot t comma x, that's all. Okay, so after this you can obtain the like continuous signal. Okay, so what is a continuous signal means? So it will be in the in like sine wave. Okay, so yes, I will show you correctly. Okay, so here you can see this is, there is a complete sine wave, that is called as continuous signal. Okay, when it comes to the discrete signal, there will be a difference. Okay, that will also we will execute later. So first understand the continuous signal. Okay, so in the electric vehicles all the values should be in the continuous. Okay, so when it becomes discrete means there is a problem. Okay, so after this we will execute one more example related to the continuous signal. Okay, so that is regenerative braking current. Okay, how we will calculate the regenerative braking current means, so first we will use a t value. Okay, we will take the time. Okay, time is equal to 0 is to 0.001 is to 1. Okay, so this is a time from 0 to 1. It will count 0.001 every time. Okay, so now we have taken the t value, then we will calculate the regenerative braking current. Okay, so for that you need to write x is equal to -5 into exp exponential bracket minus t. Okay, so this is a regenerative braking. After this you can plot, okay, t comma x. Okay, now semicolon. So save this program as signal 2. So after that we will got the continuous signal. Okay, so this is called as continuous signal. We got the time versus regenerative braking. Okay, so this is a continuous signal. Okay, so vehicle is in the regenerative braking time. Okay, so here from -5 it is increased up. It is increased up to -2. Okay, for the time duration of 0 to 1. Okay, so in this duration the signal is generated from -5 to -2.2 something else. Okay, now so this is called as continuous signal, and this example is for regenerative braking current. Okay, now so then we will try the examples based on the discrete. Okay, so for the discrete discrete EV signals, this is a comment. Okay, yes. So then we will take a variable and save it 0 is to 20. Okay, now so after this we will calculate some values. Okay, so we will take battery readings or speed samples, motor RPM samples, or anything. Okay, you can take any samples and you can obtain the discrete signals. Okay, so first we will take the speed. Okay, now speed sample we will take a variable called x. Okay, we will calculate the speed samples. So you can write it as 60 plus 5 multiplied by sine 0.2 into pi into n. Okay, so after this you can just plot the graph, like use stem n comma x. Okay, done. So now we will plot the discrete signals. Okay, now save this as the like d signals 1, that means discrete signals. Okay, 1. Yes, we got the discrete signals here. Okay, this is not a continuous signal, this is a discrete EV signals. Okay, we got this multiple samples. Okay, so here we got the 60. Okay, then we got 64 something else. Okay, so this is called as discrete signal. Before the old examples are the continuous signals. Okay, so here we have plotted the samples. Okay, which is related to the speed of the electric vehicles. Okay, now like this you can generate the discrete signals using the formula. Okay, so here we have sampled the speed of the electric vehicles. Okay, so like that you can make it for the different values for the electric vehicles, like battery, voltage, current, motor RPMs. Okay, current sensors, temperature samples. Okay, you can collect these samples and you can plot the discrete signals. Okay, now then we will try one more examples which is related to the battery reading. Okay, battery readings, let us check it. So first one is speed samples of EV. Okay, so then we will write the battery readings. Okay, so for that you need to take x is equal to 48 volts plus, then we will take the random data from 1 comma, so let us check the length of n. Okay, semicolon. This is the battery readings. So then you can plot the discrete value for this. Okay, now so this one you need to write after this line. Okay, now we will comment it, this one we will comment this line and we will run this program. Okay, so here we got an error because undefined length, so here we have written the spelling wrong. Okay, length. Yes, we got the samples. So these are the samples from the battery voltage. Okay, so these are the random values. Okay, like the values between 45 to 50. Okay, 50, 52, there is a maximum value also above 52 and all. Okay, these are the random values where you have obtained of the discrete graph. Okay, using these values. This is the battery values. Okay, second example is battery readings. Okay, so then we will try one more example which is related to the motor RPM. Okay, so motor RPM, so we will take an x is equal to 1000 plus 100 into sine bracket 0.3 into pi into n. Okay, so after this you can just plot the graph stem n comma x. Okay, now so after this we will plot the discrete signals using this formula. Okay, so this value is from the motor RPM samples. Okay, motor RPM samples. Then we'll run the program. So before that we will comment this line. Okay, then click on the run option. Now we got the samples based on the motor RPM samples. Okay, the samples are like 1000, 1100, okay, 1150. These are the based on the formula. Okay, but this example is based on the random values. This example is based on the formula. Okay, whatever the formula you will write, those values will be reflected in the graph. Okay, which is discrete graph. Okay, so these are discrete. Now you came to know difference between continuous and discrete signal. Okay, so when you run the continuous graph, okay, it will be like this. Okay, this is a continuous signal. So yes, so here you can see that this is a complete continuous signal. Okay, now so I will show the difference between continuous and discrete. Okay, this is a continuous signal. Okay, then I will show discrete graph. Okay, we will compare both. Yes. Okay, now so here we got the discrete signal. So it will be like dotted and lines will be towards downside. Okay, now so and there will be a certain samples collected, but when it comes to the continuous signal, there will be no samples. The values will be in the continuous form. Okay, there will be no samples in it. Okay, there is only continuous values where you can collect the samples in it. Okay, now like this, there is no samples here. There are continuous values. You can read it from 46, 46.2, 46.3. Okay, like that, every point matters inside the continuous signal. When it comes to the discrete, there will be a like limited samples. You can just directly read it. Okay, so here I can read it as 1000 value. Okay, then the second sample is from 1100 something else. Okay, near to 1100. Okay, next there is a 1150 like value sample. Okay, these are the samples. Okay, in the discrete signal you can identify the samples and exact value. Okay, but when it comes to the continuous signal, you cannot identify any values in the graph. Okay, now so let us try one more example which is related to the we'll do based on the temperature samples. Okay, temperature samples in the battery. Okay, now so for that you can take x is equal to 25. That's 25 is the normal temperature plus 0.5 into n. Okay, now so let us write this line after the program. Okay, now okay, done. So let us run this simulation. Here we got the temperature. Okay, rising temperature. So it will add 0.5 every time. Okay, n value 0 to 20, it will add 0.5 every time. So that is called as discrete signal, and this is an example for the temperature. Okay, temperature samples, nothing but a temperature samples. Okay, now so like this you can obtain the discrete signals using multiple formulas. Okay, so there are multiple examples. Okay, so you can take anything in the electric vehicles. Okay, you can do current sensor data. Okay, you can take throttle inputs. Okay, you can take brake signals, and let us try this throttle input. Okay, how to calculate the throttle input means x is equal to, so let us take a random value. Okay, random value 1 comma length of n. Okay, now so let us run this one. So So we got the random graph. This is for throttle response. Okay, now. So throttle response or throttle, you can input, throttle input or throttle output. So I will comment it down. Okay, this is an example for the throttle input. Okay, now. So when an electrical vehicle is accelerated, okay, it will be like this. These are random values. Okay, now. So when it comes to the continuous, there will be no samples, only continuous signals. Okay, here we got the samples at the exact time interval. Okay, so execute these different types of example programs related to the discrete. Okay, so you understand the continuous signal. Okay, these graphs are based on the discrete signals. Okay, so don't confuse between continuous and discrete signals. Okay, both are different. So after this we will move to the next topic. Okay, so that is time domain representation. Okay, now. Yes. Okay. So now we will discuss about the time domain representation. Okay, so what is it means? Write on the example definition. Sorry. Okay, signal variation over time. Okay, so that is known as time domain representation. Signal variation over time. Okay, so you already like plotted the continuous signals and discrete signals. Okay, there we have like obtained the values based on the time interval. Okay, so similar here also we will obtain example. Okay, speed versus time. Okay, current versus time, voltage versus time. Okay, anything with versus with respect to the time, that is called as time domain representation of when you are plotting any graphs. Okay, now. Okay. And when it comes to the electric vehicles, okay, so let us take an example of speed versus time. Okay, so at driving profile, okay, based on the driver. Okay, so you can tell it as at driving profile. Okay, now. So after this you can take the current versus time at energy usage. Okay, energy usage. This is also you can tell it as time domain representation. Okay, now. Okay, so let us do some examples related to the time domain representation. So first, as it is, we will take the variable called t, which is time. Okay, first the time should start from 0. Okay, it should increment 0.01 every time till 10. Okay, now. So this is a t value. Okay, then we will plot the graph based on the time domain representation. Okay, so for that you need to here you need to write, this is correct, so here you need to write is to, okay, not semicolon. Yes, So after t we need to directly you can plot the graph. Okay, so what we will plot means t comma, okay, t comma. So here we have taken not taken any variables. Okay, directly you can write the formula. Okay, t comma. So now we will write it for acceleration. Okay, now so acceleration we will write it as diff. Okay, and we will write array 0 t. Okay, now close the brackets, semicolon. Okay, now done. So let us check the acceleration graph. Okay, yes, time domain 1. So graph will be inside the here in the taskbar. Okay, you can go here and you can check it. Okay, this is called as time domain representation. Okay, so here we have plotted the graph 0, 0.01. Okay, this one 0 and t 0 t value is nothing but 0.01 10. Okay, now so for the smoother output you can just change the formula here. Okay, so I will change the formula. I will remove this acceleration option and we will write the battery discharge value. Okay, that is 100 minus t into 2 into t. Okay, so you can run this example. So now we got the graph, okay, which is respect time versus battery discharge. Okay, so here there is a battery percentage is 100. Okay, the time is 0 to 10. Okay, so it is decreased the battery discharge up to 80%. Okay, in a 10 seconds. You can tell it as 10 seconds or 10 milliseconds or 10 minutes, anything. Okay, so with respect to the time, the battery is discharged from 100 to 80%. Okay, so you can plot like this based on the time domain representation. Okay, so this one is a time 0 to 10 is nothing but a time, and this one is a battery discharge. Okay, battery here the battery is fully charged. Okay, 100. Here the battery is 80% discharge. Okay, 80% means nothing but it discharged 20%. Okay, now so battery is down from 100 to 80. Okay, this graph is obtained. This is called as time domain representation. So and also you can try it for one multiple formulas. Okay, so let us try it for motor current. Okay, so how to write for the motor current means, so t comma the motor formula is 10 into sine of t. Okay, so this is the motor current. Okay, so first one this is the time, second one this is the battery discharge. Okay, so this one motor current. Okay, now yes, so here we got the motor current. Okay, now so here formula we have written 10 into sine of t. Okay, sine wave we have generated a sine wave here. Okay, so with respect to the time 0 to 10 we have generated the sine waves. So sine wave will start from 0, maximum value is 10, minimum value is minus 10. Okay, so as per the formula we have obtained the time domain graph. Okay, okay, so let us try one more, that is plot. So let us try it for torque. Okay, now torque we need to type plot t comma, so the torque value is 20 multiplied into sine t, okay, into exponential of minus 0.1 into t. Okay, now so this is a formula for the torque calculation. Okay, so EV torque. Let us run this simulation. Yes, so this is the this is based on the equation we have given. Okay, first it will plot the sine wave. Okay, 0 to around 18, 0 to 18 side. We have done 20 into sine t. That's why it is here we got the waveform like this. After that, it is taken this value exponential of the minus 0.1 of t. Okay, the graph is reduced. Okay, now so you can increase this 10 to 20. Okay, let us see what will change in the graph. Okay, like this. So with respect to the time, the graph will be this wave, the waveform will be reduced. Amplitude of the waveform will be reduced with respect to the time. Okay, now so like this you can change the time interval. Okay, I will change it to 50. Let us check the graph like this. Okay, so for every execution it will do these calculations. Okay, after doing this calculation the waveform will reduce. Okay, now like this we can obtain the time domain representation, signal variation. Okay, signal variation over the time. Okay, now so here there is a one portion of the signals. Okay, so here there is a one portion of signals. Okay, you can see the difference between 0 to 5 and 15 to 20 or anything. Okay, there is much more difference compared to the every time intervals. Okay, now yes, so you can try it for one more value, that is charging or temperature or regenerative braking, power consumption. Okay, so let us try it for power consumption. For that you need to write t, plot t comma, so here we are writing it for power consumption. Okay, 60 plus 10 into sine t bracket close dot into star 10. Okay, now semicolon. So this is for power consumption. Okay, so here we have missed the bracket. Okay, 60. Okay, 10 into 10. This is a power consumption calculation. Okay, so let us execute this. Yes, we got the graph. Okay, now so here you can see the waveform from 0 to 50 time intervals. Okay, so we'll change this time intervals to 10. So here you can see this is a time interval from 0 to 10. Okay, so there is a changes. Okay, here it is started from 600. Okay, but here at the 10 it is ended with something around 445 something value. Okay, now there is a slight changes in the waveform. Okay, you can observe it. Okay, now like this you can obtain the time domain representation for different time intervals. Okay, now so these are the examples for the time domain representation. So whatever the graph you are plotting, every graph will have the time intervals. Okay, now so after this we will generate some signals. Okay, so it can be step, ramp, sine wave. How to generate these signals using the MATLAB. Okay, now so let us move to the next concept. Okay, so here we will use signal generation. Okay, signal generation like ramp, okay, step, sine, okay, in EV. Okay, I forgot to comment this line. So we'll just comment it down. Okay, now signal generation like a ramp, step, sine in electric vehicles. Okay, with respect to electric vehicles. Yes. Who is that? Okay. So in a signal generation like ramp, step, sine, okay, so you can generate multiple signals using the instructions. Okay, first we will try it for sine wave. Okay, so for the sine wave, so when it comes to the step signals, okay, step signals will be inside in the values like throttle. Okay, so if you throttle suddenly, then you will generate the step wave. Okay, now so we will try it first. Okay, so take down the first example. So first we will take the time. So time, it should start from -1. Okay, it should increment 0.01 every time. So the maximum value will be 1. Okay, now semicolon. Okay, so after this we will calculate the for the sudden acceleration. For the sudden acceleration, you will write you will take the example, we will take the variable called u is equal to t is more than is equal to 0. Okay, semicolon. Okay, now okay, so let us try this one. Signal 3. Okay, I will save it as signal 3. Okay, so then we will write it as plot t comma u. Okay, now semicolon. Yes, we got the step wave. Here you can see there is a blue mark here. Okay, so that is a step signal. Okay, we got the signal like this. Okay, here you can see there is a small step wave, step signal. Okay, now okay, so it starts from 0. Okay, and conversion is done in at the 0. Okay, so after that, again here you can see here. Okay, now so at the 1 it is turned. Okay, now so this is a step wave. It started from here. At the 0 it is done vertical direction, and after that 1 here in the y-axis. Okay, so it is a horizontal. Okay, this is called as step wave. Okay, now okay, so this is sudden throttle. Okay, now so example for the sudden throttle in EV. Okay, done. So after that we will execute one more example, that is motor on or motor off. Okay, let us try that one. Simple, you need to take a variable u. Okay, so we will calculate only u because here we have taken the time. Okay, now so time will be common for every example, just u will be changing. Okay, u is equal to t is greater than is equal to 0 into 100. Done. So let us see the waveform. Yes, same 0. Okay, now it is gone to 100. Okay, 100, then it is vertical. Okay, vertical. This is horizontal, 0 from -1 to 0. Okay, after that based on the y-axis it goes 0 to 100. Then at the 0 at the 100 y-axis it turns horizontal till 1. Okay, now like this we have obtained the step wave. Okay, now like this. Done. So you can try it for one more example. This is for motor on or off status. Okay, motor on. Okay, so then we will try one more example. So let us try it for whether the headlights are on or off. Okay, for that you take variable u is equal to bracket open t is greater than is equal to 0, close the bracket, into 1. Okay, now semicolon. Yes, same here, 0 1 and here 1. Okay, so like this. So all the step wave is nothing but like here this design. Okay, now so let us move towards next, that is the ramp signal. Okay, so let us generate the ramp signal. So how to generate the ramp signal means just we will take the variable called r. Okay, you can take anything. R is equal to t into bracket open t is greater than is equal to 0 semicolon. Okay, this is for ramp. Okay, na? So here you need to use plot t comma r. Okay, it will generate the plot based on the r and t. Okay, let us try it. Okay, so this is called as ramp signal. Okay, now so here like 0 to -1 to 0 it is same. Okay, in a vertical. Okay, but after 0 like it is incremented in a slant till 1. Okay, this is called as ramp signal. Okay, now and you can show it as an example of speed. Okay, with respect to time. This is a time, it is a speed. Okay, now like this you can obtain the ramp. So here we have done the examples related to the step signals generation. Okay, and from here we have generated ramp signals generation. Okay, then after this so you can try multiple examples. So let us this one is for the speed increase. Okay, speed increase example. Okay, na? So next we will try it for one more example. So that can be battery charge increase. Okay, let us take r is equal to 10 into t. Okay, na? So let us calculate this one. So here we got the ramp signal. Okay, now -10 to 10 like this. So battery charging, while the battery charging, so it goes from -10 to 10 as per the calculations. Okay, now done. So this is for battery charge increase. Battery charge increase. Okay, let us try one more example based on the temperature rise or load increase, speed decay or anything. Okay, so let us try it for the speed decay. Okay, so speed decay r is equal to minus t semicolon. Okay, so let us check it. So here you can see this is a ramp in the opposite direction. Okay now, so we have plotted the graph for the speed decay. Speed decay means so when the speed increases, okay, that is called as speed increase. When the speed decrease, it is called as speed decay. Okay, so from positive to negative, okay, the speed is decreased, that is called as speed decay. This is a ramp signal. Okay, so after the ramp signal we will generate the sine signals, okay, which is based on the this after here we have done the step signals. Okay, so for the step signals we can write it for as plot t comma u. Okay, this is for step. Okay, plot t comma r is nothing but a ramp signals. Next we got the sine signals. Sine signals generation. How to generate the sine signals, okay, with respect to electric vehicles. So here we will take the t value. So t value we will take it as same, okay, but here we will take it as positive. T is equal to 0 is to 0 comma 01 is to 1. Okay, so this is a time t value. Okay, so after that we will we will do the like assign the sine value. Okay, so sine value we will take as s. S is equal to sine this is a motor AC current. Okay, so for the motor AC current we will calculate the equation as sine 2 multiplied by pi into 50 into t. Okay, bracket close semicolon. Let us plot t comma s. Okay, done. So let us run this equation. Yes, so here we got some disturbance. Okay now, so there is a small correction. Let me check it. To 1. Yes, sine wave, it has some calculating issues. Okay, so let us try one more formula. Okay, so this is for motor AC current. Okay, motor AC current. Okay, then we will try one more examples related to the wheel imbalance. Okay, let us try it for the wheel imbalance. For that we will take S is equal to sine two pi 10 into t semicolon. Okay, so this is for wheel imbalance. Okay now, so it is like it is giving some issue. So let us take a new scripting file. Okay, for the sine wave. Okay, we are getting some error here, so we will take new scripting file and we will execute in that. Okay now, so I will comment this line. Yes, so here you can see we got the actual sine wave. Okay now, so this is for wheel imbalance. Okay, so let us check it for motor AC current. Okay, we will comment this line and we will remove this line. This is a motor AC current. Okay, so we got the same signals. Okay now, So yes, let us try one more examples related to the sine signal generation. Okay, so next we will try it for sensor signal. Okay, sensor signal or combined, like we'll try it for noise in the motor. Okay, let us try for the noise in the motor. For that, S is equal to sine 2 into pi into 200 into t. Okay, yes, let us try it. Yes, so this is a noise in the motor. Okay, so based on the road condition, okay, or else based on the acceleration, okay, this is a noise signal generated in the motor. Okay, yes, so after this we got the next topic, that is sampling concept. Okay, a sampling concept. Okay, so we are done with this sine wave generation. So after this we have the topic called sampling concept. Okay, now so write down the definition, like sensors at ADC. Okay, a digital controller. Okay, that is called a sampling concepts. Sensors at analog to digital converter at digital controller. Okay, now so this is called as sampling concept. Okay, so after that we will execute some examples based on this sampling data. Okay, sampling concept. So first example, we will take the variable t, time. T is nothing but a time. 0, it should start from 0 and it should increment 0.001 is to 1. Okay, semicolon. So after this we will calculate the x. Okay, so this is a motor signal. Okay, let us say this take motor signal. So we will calculate sine 2 pi into 50 into t. Okay, so this is the motor signal. Okay, now so then we will plot t with respect to x. Sampling 1. So we got the waveform like this. So this is the sampling concepts first example. Okay, I will show how to take the samples. So after this formula, you need to take value. Okay, value we will take it as sampling. Okay, sampling we will take it as 50 samples. We will collect the 50 samples and so then we will again calculate one more example program, that is speed sensor sampling. Okay, speed sensor sampling we will take it as xs. The formula is sine 2 pi into 50 into 0 is to 1 divided by fs is to 1 bracket close semicolon. Okay, so here we should plot the graph with respect to t and xs. Okay, So excess, here we will take it as fs. Sorry. Okay, so there's some correction here. Okay, so we should plot the graph based on the t comma x. Okay, so here we will take it as x. So let us check it. So we got there. Yes, so here we have missed some lines. So after this fs is equal to 50, okay, we need to write fs is equal to 200. Okay, so these are the samples. Okay, again fs is equal to 1000. Okay, again fs is equal to 10, 20. Okay, so after this line we should write xs is equal to 48 plus sine 2 multiplied by pi, okay, 5 into 0 is to 1 divided by fs is to 1 semicolon. So after this you can write plot t comma x. Okay, then you can write hold on. Okay, then stem 0 is to 1, fs is to 1 comma xs semicolon. Okay, this is the actual program. Okay, then yes, we'll try to execute this one. Yes. So here we got the samples. Here you can see there are multiple samples. Okay, so at 50 we got some samples. Okay, now like this you can obtain the multiple samples in the same program. Okay, so these are sample concepts. Okay, done. So this is about all the concepts. So first we have done the signals, continuous signals and discrete signals. Okay, these are the examples. Then these are the discrete examples. Okay, then we have done time domain. Okay, so in the time domain we have like plotted the graphs based on the time intervals. Okay, then after we have done we have generated the step signals, ramp signals. Okay, then we have generated the sine signals. Okay, so after this at the last we have done the sampling concepts. Okay, so these are the scripting topics for the today's class. Okay, so try to execute more examples, okay, based on the different topics. Okay, now, and if you have any doubts related to these concepts, please just unmute the mic and ask, or else you can just put a message. Okay.